Welcome back to the OpenVINO channel. On video 18, we presented the Intel integrated graphic, the GPU. We demonstrated how to use it for inference. On video 44, you can see how to use the fixed functions inside the GPU for video encode, decode, and even image processing. So the integrated GPU is performing multiple operations, and we need a way to gauge the utilization of the various functions. Maybe we'd like to make sure we're using not more than a certain percentage of the GPU and leave some headroom for other applications. Maybe we need to know if the performance bottleneck is a decoder or the inference and so on. There are multiple tools to do that. VTune is probably the best I'm aware of, but I'd like to show you a simpler tool you can just start and use even today. The tool is called MetricsMonitor. You can find lots of documentation if you just Google it. MetricsMonitor is part of Intel Media SDK and provided with Intel OpenVINO. Of course, you need to have OpenVINO installed and the OpenCL driver for the integrated GPU working. Watch video 18. The MetricsMonitor is part of the Media SDK samples. First stage is to build the samples. You'll need sudo permissions. Initialize the OpenVINO environment, go to the samples directory, create and build the directory, cmake and make. In _bin/x64, you'll find the Media SDK samples, Decode sample, Encode sample, and so on, but also the MetricsMonitor. Let's open a new terminal. We need sudo permissions, go to the Media SDK samples, and run the MetricsMonitor. Now we can see the execution units utilization under render, but also the utilization of the fixed functions for decode, encode, and image processing. We call VDBox for video decode box and VEBox. These are the middle columns marked video, video 2, video E. And we can see the frequency of the GPU. Right now it's about 300 megahertz. On this video, I will just run top to gauge the CPU utilization. First, let's run inference on the CPU. I'm running the benchmark utility, check video 32. You can see that the CPU is at more than 300%. I have 2 cores on this machine, 2 threads each, so 4 logical cores, and 3 of them are fully utilized. The GPU, however, is totally idle. Now let's run the same benchmark on the integrated GPU. You can see the execution unit utilization is going up to almost 100%. The GPU frequency is going up to 1 gigahertz, and the CPU is still working, but went down from 350 to 100%. So we've taken the load of more than 2 cores and offloaded it to the GPU, and now the CPU can do much more. Now let's take another example. I'm taking a video file and I will decode it first on CPU only. And you can see that the CPU is at 300%. The GPU is of course idle. Now let's run the same decode on the GPU, and you can see that the GPU fixed functions, the decode fixed functions, are going up to 100%. The GPU frequency to 1 gigahertz, and most important, the CPU is only at 100%. So we saw how to take tasks like inference and decode from the CPU to the GPU that is anyway idle, and by that offload the CPU and basically get more out of your system. The integrated GPU can decode, encode, and even perform video processing. Use it. Subscribe to our channel to get more videos like this one. Thank you.